Hi everyone, I'm Lion, an engineer passionate about aerodynamics and hydrodynamics. If you enjoy my small-scale engineering projects, don't hesitate to follow me and stay tuned. Reducing pollution and CO2 emissions in aviation is an unstoppable trend. While hydrogen-powered aircraft are becoming the main development direction here in Europe, electric propulsion, especially for smaller aircraft like trainers, business jets, and private planes, is clearly another promising path. The aircraft I'm building by hand is actually an electrified retrofit of a traditional fuel-powered propeller engine. Let me briefly share what I used in this project. Choosing the electric motor and matching battery pack, the weight issue bothered me for quite a while. Stability analysis with XFLR5, basic aerodynamic modeling, and performance estimation using OpenVSP. Precise CFD calculations on key components using Strass-EM. Structural and strength testing of the wings with ABAX. What I thought would be a simple project ended up drawing on just about everything I've ever learned in aerospace engineering. In this first part of the video, I'll talk about selecting the electric motor and the battery system. My goal is to retrofit a small airplane that meets Europe's Class 3 standards, which means keeping the maximum takeoff weight under 600 kilograms. Given the need for at least 0.5 hour of endurance, it's been extremely difficult to find a motor and battery combo on the market that fits both the weight and performance constraints. I'm not an expert in battery technology, but I really hope we'll see super batteries in the future, like solid-state lithium metal batteries, that could finally make true electrification practical. Imagine building a huge plane, powered by lots of tiny engines and just a handful of small batteries. That would be a dream. The battery needs to be light enough, but its size is also a critical constraint. Considering the aircraft's stability and aerodynamic characteristics, it's clear that, unless something very unusual is done, the battery really needs to go in the nose of the aircraft. This means I had to redesign the nose section, both to fit the electric motor and the battery pack. Enlarging the nose changes the proportions of the aircraft, so I also had to adjust the overall structure to maintain good stability and aerodynamic balance. To maximize flight endurance, I aimed for at least 30 to 60 minutes of flight time in this initial prototype. The first step was to find an electric equivalent to the traditional power plant. My reference was the Rotax 912 ULS, a widely used piston engine in light aircraft. There are several electric motors on the market, such as the E811, that offer similar performance. Under weight and size constraints, the battery pack must be capable of delivering sustained power for as long as possible. Taking the E811 as an example, its typical continuous thrust power, about 65% to 75% of its maximum continuous rating, ranges from 31.98 kilowatts to 36.9 kilowatts at around 2,000 revolutions per minute. Compared to the Rotax 912, which operates at up to 5,500 RPM, the electric motor runs at a lower and more consistent speed, making the flight smoother and quieter. Based on a power draw of 35 kilowatts, this dual battery pack setup can provide approximately 0.68 hours of flight time. Each battery pack weighs about 75 kilograms, so the total weight of two packs plus the electric motor comes to around 180 kilograms. Since it's still very difficult to find practical data on solid-state super batteries, I'm using this setup as a baseline for testing and performance estimation. There are already several successful electric aircraft projects around the world. For example, the Aviation Alice is powered by two Magni 650 electric motors combined with high-energy density lithium-ion batteries, aiming for a flight range of 800 kilometers. Meanwhile, Rolls-Royce's YASA axial flux motor, paired with high-performance lithium batteries, has already completed over 600 kilometers of flight testing. These successful cases represent a clear trend in aviation. The future may lie in full electrification, or perhaps in hybrid systems combining electric and hydrogen power, or even in pure hydrogen-fueled turbofan and turbojet engines. Whether it's low-carbon aviation, urban air mobility, or flying taxis, all of them will depend on new forms of clean energy to make this future a reality. Looking at the design draft with only 0.67 hours of endurance, it might sound decent at first, but that's really just for Class 3 light aircraft. In actual use, the real-world demands go far beyond that. When working on electric aircraft conversions, we can't help but hope for a real breakthrough in battery technology. Only then will these optimization efforts truly have practical meaning and long-term value. Now that I've selected the test motor and the matching battery pack, in the next video, I'll be testing the power system to see if it can meet the basic flight requirements. If you enjoy my small-scale engineering projects, don't hesitate to follow me and stay tuned. Thank you for watching. See you next time.